Okay, so Andy Shrimpton at gaatech.com, just going to give you a quick introduction to 3D printing, how once you've got your printer you can get a model off the internet, get it into your software and then get it printed. So this is Cura, comes free with the Ultimaker, and I'm not going to go into how to use the software, just going to basically show you how to get a model into the software and then how we print it how we print it on the printer. So this is this screen here is representing your build platform of your machine. So we're going to go to load a file, so click on load, and obviously I've got my own STL files. That's the native format that the printers use. But as in the article, there's lots of free resources on the internet, Thingiverse being the well-known one. You can log on there and you can find pretty much what you need. People have uploaded these things for free, where I'm doing custom design prints for myself. So I'm just going to select one that I've done, and this is one part that we just are going to see in the video. So this is a wedge. So you can see that I can rotate the platform around and I can see my part. Now the parts come in because the way it is drawn, it's landed flat on the build platform. But if it doesn't come in flat on the build platform, you can change the orientation by twisting it round. As you can see here, I'm twisting it round. So I would be twisting it round to make sure that the flattest part and the widest part of the model was going to be on the build platform, because obviously it would stick better, and that's all we need. We want to make sure that the model sticks on the build platform. So that's it. That's now in the software. If you wanted to make multiple parts of it, you can just click on that, right click, and say you want multiple objects. Tell them how many you want, and it's telling me here, it's come up with a warning the way it laid it out on the build platform. The one here is in grey, which means it's actually fallen off the build platform. Just say yes, and it moves the parts back into the build platform area so you can print it. If you, for instance, say you ask for 8 of them, or say 12 of these, and only 8 fitted on, it would tell you that you're only going to get 8, and it wouldn't allow you to print the others. So that's it, and then you can just delete them because I don't want them all. And you can see here we have the build time, 31 minutes. It's going to use 0.86 meters of material. It's going to weigh about 7 grams, and once you ask for more, it'll recalculate the time. So 3 now is going to take 1 hour 40, 2.6 meters, and they're going to weigh 20 grams. So it's just giving you information. So if you're running low on material, you can estimate that you've got the right amount. So we've now got our part on the build platform. In my software, it highlights in orange, and I believe those colors are customizable. So it means it's going to build. There are settings on here. So the basic settings, you get a fast print, normal print, high quality, and ultra high quality. So a draft print here saying it's going to take 30 minutes. A normal print, all this is doing is altering the layer height. So the higher the quality, the lower the layer height is going to be. Normal print is 1 hour 24, high 2 hours 20, ultra quality, which is some stupid resolution, I think it goes down to 0.02 of a millimeter, and that's this little block, and the little block is only how wide is the block? The block is only roughly 70 millimeters by 25, so it's not very big. So on ultra high quality, and on ultra high quality it's 0.04 of a millimeter layer height, so incredibly fine detail. but you can see the print time is absolutely massive. So I'm going to jump back into quick print, and I'm going to select fast print. Now when you do that, the machine is preset with defaults for you, so if you ask for fast print, it knows you'll want a draft type print, and it will give you the basic settings. But you can go into the software, so if you go on the expert button and click down to switch to full settings, what it's going to do, it's going to carry the fast print settings over into a menu where you can customize. So you can see here now layer height up in the corner, it was actually going to print at 0.15 millimeters, and I'm going to change that to 0.2 because I know 0.2 is good enough. Shell thickness, it's come up as in yellow because it's not a multiple of my nozzle size. So my shell thickness, I'm going to change that to 1.2 because my nozzle is 0.4. The yellow will disappear. I've enabled retraction, so that will allow the retraction to work, and that is where the head is moving across the part. Not so important for this part because it's really a box really. Nothing complicated. It's going to print very easy without retraction. When retraction comes into its own is where you've got complex parts where the head has to move across the print area without extruding material, and you don't want it to blob, string or create cobwebs. So the retraction is a speed and a distance that you can program in of the material being pulled backwards up the Bowden tube in my case, to try and prevent those stringings occurring. Okay, so now we can select the thickness of the top and the bottom. Now 0.6 for me is fine because this is really a draft print. Fill density here, I'm going to do 20%. No, let's leave it on 10% to begin with. You can see in this software, again it's in the article, if we drop down to layers, and then you can move the slider up and down and it reveals the layers. So this is how the print is going to work. So the yellow mean it's solid, and then as it comes up you can see about layer 4 that the honeycomb, the crisscrosses lines here, the infill is starting to happen. So as the print builds up you can see that in the middle of the print here is all the infill coming in. So that was 10%. In the video that you're going to see it's 20%. So you've just changed that to 20%, and you can now see the grid becomes more dense, and that's just going to make the print stronger. So this just gives you an idea that you can see how your print's going to be made. Very useful. I've got no overhangs, so there's no problem. Although this is a wedge shape, it's just going to print straight forward. It's one of the easiest prints that you can do. The print speed here in the video, I upped that to 70. That's 70 millimeters a second. If you go too fast, it will start warning you to say that you're trying to extrude too much material out of the print head, so you just need to slow it down. Again, the slower you do it, the better quality the print's going to be. Support type here, I don't need to add supports because we've got no overhangs to do. So basically that's all the settings that really at this level we're going to do. There are other settings here where you can change the size of the nozzle, you can play with the quality settings, you can change with the speeds. Now I did change the speed of the bottom layer, so although we are printing the walls and everything at 70 fast, under the advanced tab we can make sure we change the bottom layer to print slower. As I said, it's important to make sure your bottom layer adheres to the platform correctly, so printing it slower will help that process. So I dropped it down to 50. Travel speed is where the printer head is travelling backwards and forwards. You can up that, and on an Ultimaker 2 they say they can get up to 250 millimeters a second, and that's really quick, but I've never needed to print that quick. Top and bottom speeds, again that's a top and bottom of the box, so we're going to call this a box. You slow it down. The outer shell is the walls, and the inner shell you can add thickness to the walls, and again you can change print speed, and you can select here I'm saying after the third layer turn the fans on. So everything in the software is customizable. They're all pretty much the same. I haven't tried. So sorry about a little break off there. We were just saying about you can change all the print speeds and that. So here it's come up in yellow to say that I'm actually trying to extrude, move and extrude too much. So we're just going to drop the infill speed down to 70, and it's just adjusted the time. So that's it. So basically, you know, you can put in a model from anywhere, put it on the print bed. You can just accept the default values and save it to the memory card. On mine, I save it to the memory card and then take it to the printer, put it in the printer. On the drop down menu, say that I want to print it, and then the printer does everything else. In my printer, I set the temperature, well, I set the type of material that I'm printing, and I set the temperature of the heated bed, and I set the temperature of the extruder. I believe on some software those settings get set in this space, so when you're creating the model you would choose the material and that information gets stored on the SD card, so when the code is put into the machine already knows the settings, where my machine, the Ultimaker 2, I can change the settings on the machine itself. So that's it. So you can see now this or two of these shapes being printed in the attached video, and although they look the same, they are slightly different, and what they are for, it's just prototyping some mounting blocks for a small, just hold this up, a small model aircraft. So this is a small helicopter, so you have 4 arms on here, a motor, and it flies, where I am prototyping some new arms. So instead of having 4 arms, you're going to have 2 arms, and these are beefier arms. You can see the size difference. So that's that. So that's going to go on there, and the blocks you see being printed are part of the mounting assembly for that. So that's it. So for me, 3D printing is really an invaluable tool. It's sometimes quicker to 3D print something like this than trying to CNC route it in the workshop. So, you know, for prototyping, it's a fantastic tool. I'm just going to get something very quickly. So I should have prepared that a bit better. So this is extruding a material to 3D print. So most home printers are going to do that, and the quality is pretty damn good depending what resolution you are printing. But then you can step up and have stuff commercially printed. So now we've got something like this. So this was printed all in one go. So we've got a compression spring, and that's, you know, I'm having to press, you know, I'm not a weakling, but I'm having to press that, because what you probably can't see is you've got the outer spring here, then you've got a chamber, and there is actually another spring inside this cone. So there's 2 springs. So it's a spring inside a housing, you've got the outer spring, then you've got a shackle, then you've got a tab with some writing on it, a shape, then you've got another shackle, then you've got a little aircraft, and that has been printed all in one go. Now you could probably print that model on one of these type printers, but the resolution wouldn't be good. And this is printed in a nylon material, and there is no there is no visible layers, because this is a powder that is melted by a laser and it's cured and it makes a shape, and it's just silky smooth to the touch. So, you know, I haven't got this model. I went to a show and this was a giveaway from the stand that people were demonstrating their industrial lasers, printers. But I'm constantly amazed of what can be designed and what can be 3D printed. And I thought I'd share that with you, because I just think that is amazing. Anyway, sit back, enjoy the video. The video starts sort of back to front. I start off with a print that's already started, and then we latch on to the other part that's been printed. Then, because the pictures is printing in from the front to the back, I leave it running. So the video is quite long. I will annotate the video so you can jump to sections where I'm talking, because I don't do a lot of talking during the 3D print video. So you can jump to the relevant sections. So that's the end of, or the beginning of, the next part of the video, and this was the introduction to 3D printing in association with RotorWorld magazine. So that's Andy from Gaatech signing off for now. Goodbye. Here you see the fans have stopped now. This is the beginning of the next model, and it's the outer perimeter is laid down to make sure the filament is coming out the extruder. And then you can see it steps in and it's now starting to do the outline shape of the bottom layer. The printers slow down. You know, I adjust the print speed to a slower setting. I believe it was 30 to 40 millimeters a second, and that's just to make sure the initial base layers stick to the build plate. If you extrude it too quickly, you can have the corners peel up. So the printer is slowed down, and then once it's done the first 4 layers, the print speed will jump up and it will start doing the infill, which is the crisscross pattern, which you saw in the earlier part of the video. It will print that a lot quicker because that's really just support structure to allow the top section to print. Now, there doesn't seem to be any logic the way that it does the initial base layers. It misses gaps. You can see it did the corner, then it's jumped over a section, then it will do a little bit more, then it will jump back and fill in the gap. It's just the way the algorithm program is written. The printer is obviously trying to work out, I'd assume, the shortest way to print the object, and that's what it comes. You can also see the fans are stopped. Again, this is all customized in the printer software, and I'm using Cura, which is an open source platform, but they're all pretty much the same. And again, you turn the fans off to make sure that the hot molten filament sticks to the base better. And I can't quite remember on this print, the fans turn on after the second or third layer. I can't remember, but I'd have to check. So there it's done the far side, now it's jumping back to the section that it missed. Now it'll whiz around the outside there. The fans have come on, so it's only done the base layer. And the reason the fans come on is to cool the filament to make sure each layer will stick to itself. So it's doing 2 passes around the outside and then 2 passes around the holes. And then it will jump back into infill the base layer, and that should be another solid layer. And you can see this time the printer's now laying the next layer opposite to the first layer, so that's what makes it stronger. So just sort of a weave like carbon fibre, the greater the orientation, or the greater the layers are opposed to one another, the stronger the base layer will be. So we're just now going to let the video run until it starts doing the infill, so probably 2 minutes more, and then I'm going to break away from the video because that's how the video started at the beginning. So this part here, you can just see here where my finger is, this is my Bowden tube where the filament is being pushed through this tube. My filament drive mechanism is the back of my printer, so the spool of filament is tucked away at the back, It's just held on by a spool holder, really, I should call it. So then the filament's pulled off the spool into the drive mechanism, and then it's pushed up through the bowling tube and then into the hot end where it's melted and extruded. So here was just finishing the second layer. Then it should whiz around the outsides and around the inner holes again. So it's going around the outside, 2 passes, round the circles. Around the outside again. Circles again, and now it's laying another layer. So what these mounts are, I've had an email while we was talking on Facebook, a guy with a ZMR 250 frame, which is a popular mini quad frame. He wants to do some experimentation in different arms. The arms on the ZMR 250, and I'll just splice in a picture of that into this video, has 4 individual arms, and he wants a uni arm, so the arms are joined together, so you only have 4 mounting bolts mounting the arms. Sorry, you only have 4 instead of 8. Plus the arms are in one piece, so technically it's stronger. And then he wants to experiment the way he's mounting them, so I've prototyped these mounts for him, and this is just my first draft to see whether my design will actually fit together onto the frame and give him what he wants. So once these are printed out, I will go down into the workshop and cut the arm and assemble it, and then send him a picture, see whether that's what he wants. So this is, you know, all what we do for rapid prototyping: design on the computer, print the parts out, make sure it actually assembles together. And even though it is drawn in computer, I always find that once you've got the parts together and you start assembling them, there's always something you can tweak with the design to help it assemble better, or you just see something that can be improved in the design. So whenever I do frames for clients, especially when it's their first frame, I'm talking about carbon fibre FR4 G10 machining now, I always say don't go straight to carbon fibre, have a draft cut in FR4G. Now, right, this printer now, you can just see it's sped up now, and it's starting to do the crisscross pattern on the inside. So this will now build itself like we saw at the beginning of the video, and this hatch pattern is purely there to create a structure for the top layers to be printed on. Obviously the wall thickness is designed, and I can tell it how thick I want the walls to be printed, as well as the top and the bottom layers. So several things dictate how strong the parts are. So how thick the base and the top are printed, how thick the walls are, and how dense the infill is. Now this infill is 20%. So you can see the hatch pattern is actually quite visible. I would say, looking at it, it's maybe 4 mil in between lines. Obviously the more infill you request in your print, the denser the infill becomes and the smaller the diamonds or the square patterns come, which affects the time that the printer takes to print. The more infill you have, the longer it takes to print. Now this print was 2 of these. From where we are now, we've got 28 minutes left. it was over an hour to print these two, and they are different. Although they look the same, it's going to be used to sandwich a mini quad arm together. So one of the mounts goes onto the aircraft, then the arm is going to go on, and then the top mount will go on. And the reason these are required is so that the bolts driving through the objects, these two mounts, the body of the airframe and the arm, is that the bolt can go at 90 degrees through all the parts. These mounts, you might not be able to see from the print, are actually angled at 15 degrees. So it makes sure that the head of the bolt and the nut and washer meet all the parts at 90 degrees. So I think this is just about where we started the video. I know I've done it slightly back to front, but had trouble with the camera in the beginning. So just going to leave it a few more seconds to whiz around, and then we're going to break it off. So that is a 3D printer in operation. Again, as the article says, there's many different types. This has a heated build platform, so I've set the temperature of the build platform to 70 degrees, and the extruder temperature, I can just have a quick look. The temperature of the extruder is 250 degrees, so you don't want to be touching that with your fingers, because it will leave an imprint. And every material is slightly different. This is ColorFab XT, which tends to print fairly well. Not as nice. Sorry, it's not as easy to print as PLA. PLA, as I've said in the article, is the easiest to print, but this is a good cross between PLA and ABS. ABS I tend not to print in. I don't like the smell, and it is very, very stringy. This doesn't look stringy, but when you start doing complicated parts where the head has to move from one section of the part over to the next without printing material, even though we set the retraction, and that's where when the head is moving, the filament is pulled up into the Bowden tube, so it's trying to suck the material out the print head to stop it extruding, making the strings or cobwebs. You still do get that on complicated prints. Now this one's printing the opposite way, so I'm actually going to leave the camera running, because now you'll see how the top layer is gradually built up. So remember, it's a wedge, and the thinnest part of the wedge is towards the front, so we're looking at the thinnest part. So I will leave the camera running until it's finished, and you'll see that the top layer is laid on top of the crisscross pattern, and that's how we end up with a nice 3D printed part.